Okay, Srini, hope you have a good break.
Hello.
Yep, hope you have a good break.
Yep.
Okay, let's try to finish our pure capacitor. And then we need another 1 or 2 hours to finish the whole thing. We are still right target. Then after that, we should use the revision time. Okay, let's carry on. Alternating current through capacitor. Previously, we looked at pure inductor. Now we look at pure capacitor. Then after that, we will combine resistor and capacitor, resistor and inductor, and then the three together, inductor, capacitor, and resistor. Okay, so now we are looking at capacitor, alternating current through capacitor. Syllabus-wise, as always the same, derive the expression for current. The voltage is given as your voltage supply. Explain the phase difference between current and voltage in pure capacitor. Then refine the reactance. And then from the definition, we get the equation. Derive and use a formula for power in an alternating current circuit, which consists only of pure capacitor. Pure capacitor is part. Okay, same. Power supply. There's alternating voltage, V0 sine omega t. That's your current. Charge stored on capacitor of the capacitance C when the voltage across it is always go back to Q. The charge stored is Q C times V. Right? We want current, so we differentiate that with time. Differentiate that with time. Your C is always a constant, so we get dQ dt, C dV dt. dQ dt is your current. Okay, and then your V is V0 sine omega t. So our current becomes your C. That's your current. That's your C. Okay. V0, when we differentiate this one, V0 will still stay the same. V0 stay the same. Sine becomes cos. And then differentiate omega t, we get omega. Right? So as before, we see there's a constant there. Right? We compare to, that is usually the amplitude. So that's the amplitude, C V0 omega. I0 equals to C V0 omega. These are constant. Depend only on the frequency, peak voltage, and the capacitance of the capacitor. And then we compare these two equations. Okay, we see that this one, cos comes first. We can draw the graph. This is your current. This is your voltage. So we can either look at the zero, where it's going down, where it's going down. Right? The current comes first, 5/2, or we can look at the peak value. Peak value, this is your 0, this is your 90 or 5/2. Right? So the current comes first. So we say I leads V by pi/2 radian. Okay, or we can rewrite the equation. Right? Cos omega t, we can write it as that. When your I, when an alternating voltage supply, there's a voltage supply. Right? When we differentiate that, we get this equation. I cos omega t, I0 is I C V0. Right? We're just repeating. V is I. Then we can show our phasor diagram. That's your V0. That's your I0. I0 is the head. Right? That's the anti-clockwise motion. Usually, we compare these two equations, we can see that where there's a plus there, it means lead. If it's a negative, like previously, means lag. Right? That means V is the head of, this one is I0 is the head. Reactance or capacitance. right? New quantity we want to define our I naught C V naught omega. So take our I naught down, cross multiply C omega to the other side, cross multiply, we get C omega. So it's 2 pi FC. And we can see this ratio is inversely proportional to frequency. Frequency increases, that ratio decreases. Reactor or capacitance is a ratio of peak voltage to peak current. And we can define that. I can put a C there if you want to. But since we are looking at capacitance, you understood. Reactance or capacitance, V naught over I naught. Or we can use root mean square, V root mean square over I root mean square. And that is your value. Memorize, not calculate. That's how it looks like. If we look at capacity, reactance or capacitance against frequency, rectangular hyperbola, frequency increases, right? And we know that your XC decreases, or we call it X is inversely proportional to F. One increase, the other decrease. One decrease, the other increase. Zero frequency, DC current, the reactant is infinite. Zero frequency is here. XC is infinite. Power. There's your power supply or voltage supply. That's your current that we have derived. Power we just multiply I times V. Since V naught sine omega t, I naught sine cos omega t. Right? Place in the sine omega t cos omega t with that one there. V naught, I naught is just your P naught equals to V naught I naught. So it's half. Right? Same frequency. We compare. This is the power supply. This is the power. Right? Or the voltage supply that get confusing. We call power supply. This is the voltage. This is the power. This is 2 times 2W. That's what it means. Right? Frequency of the power is twice the frequency of the AC. Then we can see that this equation tells us that the power is not constant. It varies sinusoidally. That means it's a sine graph also. Okay, so omega, this is 2 omega, remember that? That's why we get this equation. And that's how the graph looks like. This is your current. Green one is your voltage, how it varies with time. And that's how your power varies with time. Okay, so that's your quarter. This is your period. There's a time axis. So if we look at a quarter period, it's a quarter period. Power supply provides the power, right? The source provides the power. Negative means it returns to the power supply. Power returns to power supply. Stop me if I'm going too fast. Right? Mean power, yeah, you can say that this is the peak one or the hue, cut it off, replace this value here. So the mean is 0, same here. Hue, cut it off, replace this value, so it's 0. That's why it means my mean power is 0. No energy is dissipated in the pure capacitor. Right? Part of it is supplied by the power, part of it is returned to the power supply. So nothing is lost. Right? Let's more or less finish already. We are going to do some question. Let's review back to our charging and discharging. Right? That's your DC supply. V naught. That's your resistor. That's your capacitor. Right? So refresh your memory. When you put on the switch, yeah, press the wrong button. Right? Switch is closed. Sorry. Bit of delay there. Okay, switch is closed, right? Remember, the switch is closed, the current is going to be large. There's nothing here, right? So the current is going to be large. That's why current is going to be large. And then as this one charge up, capacitor charge up, the current becomes smaller. Right? So if you look at the voltage across the capacitor, the voltage start to increase because there's more and more charge there. Voltage start to increase. The PD across capacitor increases. Capacitor charges up the current. Right? Current decreases. Capacitor voltage across capacitor increases. PD across capacitor increases to that of the battery. Are you all right? It just got cut off. I don't know why. Very unstable. Are you okay, Srini?
What happened?
Can you hear me? We got cut off. I don't know what happened. Are you receiving anything? Okay. Are you all right? Yeah, Srini, are you all right? Are you all right now? Anything that's not clear?
Sir, your thing is lagging.
Say again. Say again, say again. Anything? Are we having internet problem?
Sir, nothing, no problem.
So we can carry on. Anything to ask so far this part?
No.
Okay. Internet is a bit unstable. So for alternating current, that's the graph that we have drawn previously. Right? As the alternating voltage source is turned on.
Yeah, it's a bit unstable.
Yeah, very unstable. Anyway, we should finish soon. Right? There's a voltage supply, alternating voltage supply. As it turns it on, the current will flow. Right? So we are using this formula that we have derived, I equals to C dV dt. Right? So that one, remember, this part is the largest gradient. This part is zero gradient. Right? Gradient is dV dt. Right? dV dt equals the slope of VT graph is maximum at this part there. dV dt is maximum. So that's why we get the current is maximum. Right? As we say, we switch on. This is the switch on. Voltage switch on. Current is maximum. Then as the voltage increases, the current decreases. Current is maximum and decreases. At maximum voltage, which is here, right? Maximum voltage, the charge, this one is charged completely. The slope is zero. The slope is zero. Slope is zero. So the current is zero. Right? The capacitor is fully charged at this part. Capacitor is fully charged. So as the voltage decreases here, right? Remember it's fully charged. Previously the current is moving clockwise. Now the current has to move anti-clockwise, opposite direction. That's why it goes negative. That's why it goes negative this part there. Right? That's how we relate to our charging. So the thing that remember, resistor, V and I in phase, capacitor, your V lags I or I leads V lah. That's right, by 90 degrees. Whereas inductor, V leads I. This one you have to memorize. Okay. So all these you need to remember. Let's try some question to reinforce. Find the root mean square current flowing in an AC capacitive circuit when a 4 microfarad capacitor is connected across a 880 volt 60 Hz supply. That's your reference. I got it from this place. Okay, remember this is root mean square value. What is your root mean square current? Calculate your reactance first. And after that, go to how to find the current if the voltage and reactance is given. Okay, what's your answer? Yeah, calculate the reactance first for capacitor. Remember the formula. What a value? Ken, what's the value for the reactance? You should be able to get 6663 ohm. Can or not? Treat that as a resistance, even though it's called reactance. Right? Similar to resistance in DC circuit. How to calculate the current now?
That's right.
Can or not? Can get the answer now?
$880 divide 663.
Right? 880 divide 63, so you get 1.33. Okay. Happy with that? If happy, we go to the next question.
I'm happy.
Okay, let's go to a past year question. Right, we try to finish as much as possible, and then we will try essay. Okay, so we got a lot of questions to try. A lot of essay questions we haven't done anything before. Even for resistor, we haven't done that also. Structure and essay, we have to try that. So anyway, we try to do as much as possible here. 3, 5, 10. If you cannot finish it, then you try the rest at home. Okay, a pure capacitor is connected to a sinusoidal alternating voltage with variable frequency. Which graph correctly shows a variation of XC with frequency of the voltage? Yep.
C.
How do you get C?
Memorize.
I got C memorized. I never teach you that. I think that this question is a problem question. Right? Your XC is that one there? So it means that if this is your XC, then the answer is donkey. Yeah? Rectangular hyperbola. Okay. But it is given as I root mean square. Is V root mean square over XC. So V root mean square. Right? Replace your XC here. So you get your 2 pi there. So in this case, as I say, the question is impossible to do. Here ask you XC, here put I root mean square. Right? So it's a problem mistake, problem question. Right? Compare with your equation of straight line, it should be B. Right? If you ask you I root mean square, then it should be B. Okay. Okay with that?
Okay.
It's a problem question. Okay, so it's either if you change it to X, then this is the answer. If they want root mean square, then it is a straight line. Okay, make sure you know how to derive that. Okay, alternating voltage is supplied to 200 microfarad capacitor is given by equation where V is in volt, T is in second. Maximum current in the circuit. How to calculate the maximum current? how to calculate the maximum current. Well, you must know the resistance first, and then you must know the peak voltage. How to calculate the reactance. Instead of resistance, we call it reactance for capacitor. How to calculate that? Yep, what is the answer? Ken? Find the
Boy.
What's the answer?
Boy.
Right? Find the reactant first. Remember the formula? 2 pi omega F is your this one, 300. C, convert it to farad, 10 to the power minus 6. Calculate is 16.7. Then I naught is V naught over, that's your resistance. Right? If you can work with DC, that's your resistance, or we call reactance. Now, catch. Where did you go wrong? Where was the mistake? And now for all this carelessness, 1 mark gone. Okay with that? Know where is the mistake or not?
Yeah, I realized the mistake, sir.
Okay. Okay, what's the answer? Voltage V is V naught cos omega t is applied to the capacitor. Which of the following graph shows a variation of I with time?
A.
How do you get A? How do you reason it out? Yep. How do you reason it out? Ken? How do you reason it out? Look at the answer. Right? Q equals to CV. Right? Can either differentiate it if you want to, and then get the equation. Right? Your V is this one. Differentiate it, you get cos. Okay, so it's B. Or know that I leads V. I leads V. So that is your, this is your V graph. If you remember, this is your V graph. Right? So I leads V. So if we look at this graph, compare these two graphs. Right? That's your V graph. Right? Because of that, V naught cos omega t. Have I done something wrong? Let me just think through. Have I done something wrong? Have I done something wrong? Have I done something wrong? No, correct. Right? Look at these 2 points. Look at these 2 points. Right? That one is leading. Well, either you differentiate it if you prefer, or remember that I leads V by 90 degrees. So look at this point. This is your V graph. Right? If that's your I graph, compare these 2 points. Right? These 2 points, where this is going up, this is going up. Your V comes later. That's what it means. Cannot.
Okay.
Okay. Number 12. Sinusoidal alternating voltage of peak voltage V naught, frequency F is connected across a capacitor or capacitance C. What is the maximum current in the circuit? Okay, what's the answer?
C. Answer is C.
Okay, let's see how to do it, whether you're right or wrong. Right, remember the formula, capacity, reactance, calculate it up, put in your value. And remember this value, you want I naught is V naught over X. So put your X inside there. Put your X inside there, it becomes your 2 pi X C V naught. Okay, B. Okay or not? If okay, let's go to the next question. Okay, sinusoidal alternating current of frequency 200 Hz, peak value 24 volt is applied to a pure capacitor. If the capacitance of capacitor is 4.4 microfarad, what is the root mean square value of the current in the circuit? Okay, same voltage is given. Now you want to calculate current. You must know the resistance. In this case, it's called reactance. How to calculate the reactance of capacitor? Yes, what is the answer? You have to do fast. Yeah, what's the answer?
Boy.
Okay, let's see. Right, calculate your reactant first. In your value, 2 pi, right, 200 Hz. That one, change it to farad. Get 181 ohm. Root mean square is V root mean square over X. Right? Remember, this is peak value. Don't get caught. Peak value have to change to root mean square value. That's why I have to divide by root 2. Then the reactant 181. No, donkey, where did you go wrong again? Cannot afford all these careless mistakes. Yep, where did you go wrong?
Careless teacher.
Where?
The
This one, didn't divide by root 2. Okay, overcome your carelessness. Okay, try this one. Since we still got time, I shall finish the Zoom. I know internet is a bit unstable. Okay, we still got about 10 minutes. Right? You are given the circuit, the voltage R and C. This R, this is your C. At the instant, the current in each circuit is maximum. Right? Root mean square value is given. So you want to calculate your VR and VC. What's the answer? Can?
Can is
What's the answer?
boy. I'm not sure.
Okay, let's see. Right, remember we want instant current in each case. Where is maximum? We want maximum, so we want peak value. That's why we have to, that is the root mean square value, times root 2. Okay, so we get your peak voltage to the resistor. Then capacitor, I leads V. So I is maximum. Remember, I leads V. When I is maximum, your V0 is 0. Right? That you must remember, donkey. Okay? Cannot calculate by like a resistor. You must know which one lead which one. I is maximum, then V equals to 0. Okay, forgotten? Remember your graph? Go back to your graph. Forgotten, as I say, go back to your graph. Right? I is maximum, V is 0. I is minimum, also V equals to 0. Right? That you must remember. Okay, let's try a structure question. What do you understand by the term reactance of capacitor? And then we will finish it off. I think we still got 7 minutes. What do you understand by the term reactance of capacitor? Yep.
Uh,
Definition, memory work only, nothing much.
oh.
Yeah, reactance is opposition of capacitor to alternating current, defined as V0 over I0. Can explain whether the capacitor has a unique reactance. Go back to the formula. Explain.
Sure.
Yeah, explain. Go back to the equation. The equation is 1 over 2 pi Fc. C is a capacitance, F is a frequency. So X depend on C and depend on frequency. So at a particular frequency, at a particular capacitance, X is unique value. C changes, X changes. That's what I mean by each capacitor has a unique reactance. And alternating current that varies with time, as shown in the graph, is connected to a pure capacitor of 470 microfarad. Right? What is this one? Have I left something out? Oh, yeah. An alternating current that varies with time is shown in the graph. How to calculate the frequency? Yep. How to calculate the frequency? Calculate the period first. Can or not?
Can.
What's the answer then? Right? There's 1 period, 2 period, 3 period, 4 period. So 40 equals 0.8. Calculate your T. Right? Divided by 4 is 0.2 seconds. Frequency is 1 over T. Calculate out. root mean square value. What is the root mean square value? How to calculate that? Yeah, how to calculate root mean square value? Root mean square current. Right? I peak divided by root 2. Sorry, I have to hurry up because our Zoom finishing soon. So it's 5 divided by root 2. And potential root mean square potential difference, you have to calculate the reactant first or the resistance first. Resistance for capacitor we call reactance. Put in your value. 2 pi. F is 50. Calculate that out. And then your capacitor, change it to farad. Calculate that out. And after that, voltage is R times I. R in this case is XC. Put in your value. Calculate out. Can?
Can.
If can, we will stop here. Continue to do the question. We will discuss on Saturday. Anything you want to ask?
Can I have tomorrow, Acha?
You sure you can take it?
1 hour, 1 hour, not
1 hour tomorrow, can? If you want, we can do that.
Because Saturday I got vaccine.
And
Saturday
Saturday,
I have to go take vaccine.
so you don't want a class on Saturday? You want a class tomorrow? Am I right?
Unless
Anyway, you think about it and confirm with me. Send me your message. I think there's some not stable. The internet is not stable, that I cannot hear you. Okay, you confirm with me. Just SMS me, message me. Okay, I will stop here. Okay, see you tomorrow if you want the class tomorrow.
Okay, teacher. Thank you, teacher.
Bye bye.
All right, teacher. Thank you. Bye bye.